All right, this is section 10.3, the hypothesis tests for a population mean. This parallels section 9.2 when we were evaluating and looking up t values and t-scores. It also will parallel the last section, 10.2, when we were determining if we should accept or reject the null hypothesis to determine if things were statistically significant or not. All right, just like 10.2, we have two different ways to do it. We have the classical way, or the classical approach, or we have the t value instead of the p value approach. So let's take a look at the classical approach. This is page 2 of section 10.3. In 1990, the mean height of women 20 years of age or older was 63.3 inches. Suppose that a random sample of 40 women who are 20 years of old or older today results in a mean height of 64.2 inches and a sample standard deviation of 2.2 inches. State the appropriate null and alternative hypothesis to assess whether women are taller today than they were in 1990. Is this a right, left, or two-tailed test? Okay, so our null hypothesis is that mu is the new value of 63.3 inches. I'm sorry, the old value, 63.3 inches from a long time ago. The alternative hypothesis is people are going to be taller than that now. So when we look at something that is taller than that now, we're talking about a right-tailed test. Find the test statistic so that we can make our formulation for basis of comparison based on the sample mean being 64.2. So we have to plug these values in. This formula, it's written a lot neater on the front page or page 1 of 10.3 notes. We just have to substitute our values in. So substituting the 64.2 value in, substituting the new mu in. The standard deviation was 2.2. Throw it in there. And the number of women was 40. And throw that in there. So when you put this in your calculator, again, do it carefully, maybe one portion at a time, or use parentheses. We get a test statistic value, or t sub 0, of 2.587. You can pause the video, throw that into your calculator, and see if you get the same thing that I did. Part Z. If we test this hypothesis at a 99% level of significance, find the critical value for this problem. So the right-tailed area has to be 1% of the data underneath this normally distributed curve. I forgot. Can we assume that this is a normally distributed curve? Because if we can't, then we don't even have to do the problem. How many people were selected for this? 40? Since 40 is greater than 30, we can assume normality. So I should have stated that before we even started. So let's test this hypothesis and see if it has a level of significance to find a basis of comparison. To do that, we need to look it up on a t-score table. Again, the t-score table, you can find it when you're doing your problems you just click on the link. But on the final exam, well, I guess we're taking the final exam online as well. Doing your problems, sometimes it's nice to have a printed copy of this, and this is on page appendix-14 of our e-textbook. So let's look them up. The things that I need to know the degrees of freedom. And I need to know the significance level. So the significance level, that was given in the problem, 0.01. But we have to calculate the degrees of freedom. Do you remember how to do that from section 9.2? The degrees of freedom is going to be n minus 1, or 40 minus 1, or 39. If 39 is not on the chart, we're going to use the one that's closest to 39 on the chart. But on this particular problem, 39 is on the chart at a significance level of 0.01. I get 2.426. So this t-value for the significance of 0.01 is 2.426. You know, guys, I apologize if you're looking at the completed notes, the filled in notes. I think I forgot to put the 2 in there. So do we reject this null hypothesis and write a conclusion for this? Since our t-value, 2.587, is greater than our critical t-value, 2.426, then the test statistic falls in the upper tail. The test significance is in that area, so we reject the null hypothesis that it was still 63.3. Okay? So we reject the null hypothesis. The conclusion is, we conclude that there is sufficient evidence at the significance level of 0.01 to say that women are taller today than they were in 1990. Guys, I hope this helps. Shoot me an email if you have any other questions. We'll talk to you soon.